Hi, biology. All right, well, as you know, the last time we talked about speciation, and that is, of course, the ways that new species form. And we talked about allopatric speciation, which means some kind of geographic barrier has been established that separates one species into two. And so it's due to isolation. Something's happening that's causing that species to separate their gene pools, and that separation of gene pools leads to differences over time. And as examples of that, we talked about the Wallace line. You guys watched a video about it and answered some questions about the Wallace line. Furthermore, I had you watch the hummingbird video and relate back to me what you saw there. And that is that hummingbirds found in this Amazon region, although they came from the same ancestor, based on their difference as far as height up a mountain range, is giving them different qualities and different traits than the lowland hummingbirds. And so those two have become separated over time. Furthermore, together we talked about the carving out of the Grand Canyon and how that separated a species of ground squirrels into becoming two different species over time. So this geographic isolation, it's a thing. I was thinking about, there is it in here? Yeah. I don't know if you can see this okay. Looks like a kid wrote on it some time ago. But this is showing regions where tigers can be found in India. And I believe we talked about this briefly. If you look at the sort of beige color here, this is historic range of tigers. And so those are all the areas that tigers used to be able to be found in this area of the India. And over time, these ranges got filled up with agriculture land, cities, people, roads, things that block the tigers from being able to get from one spot to another. And so maybe at one time this entire area was tiger habitat, but over time it gets dwindled down to just these green patches where tigers can still exist today. And so this is another form of geographic isolation where these tigers are not going to be able to interbreed anymore. They become distinct little species over time. And so those were our examples of allopatric speciation. Today we're going to move into what's called sympathetic speciation. And I suppose I can rewrite this so that you feel like we're doing it together. So sympathetic speciation is where a speciation event is going to occur in the same environment. So speciation and this is something that more than likely is because of something we call reproductive isolation. Reproductive isolation can either happen in what we call pre-zygotic or post-zygotic situations. So let's make a list of what pre-zygotic means first, and then some things that can cause pre-zygotic isolation. So pre means before, and zygotic means zygote, and the zygote is the fertilized egg. So this is something that would have to occur before fertilization. So this is before fertilization of the egg. And so so you have to form a zygote or not form a zygote. So this is something that's going to happen pre that. One of the big things for birds, and I know I had you guys watch that bird video with the different fancy birds of paradise. And the way they need to get mates is by doing the right dance, singing the right song, figuring out how to get a female to go with them is a big part of their mating ritual. And I'm glad you did watch it. If you haven't watched it yet, please go back in time on the Google Classroom, find it and watch it. What we're watching there, what we're witnessing is failure in some birds' cases to what we say illicit mating behavior. So if you can't get a mate to mate with you, that's it. It can create a speciation event. And this has happened with frogs not doing the right mating call. It has happened with birds that aren't doing the right dance or whatnot. So in this, in other words, there will never be a baby. There will never be a zygote if you can't get mating behavior to roll. And this is done oftentimes with dances, with songs. This has been witnessed also in whales. As far as the whale songs go, whales are very particular about who they mate with, and they're only looking to mate with males, apparently, that are singing the right song. So songs are a big deal, dances are a big deal. Location might be a big deal, but in this case, because it's sympathetic speciation, we're not really focused on location. So subpopulations can occupy different habitats. And we saw this, of course, way back before we left school with those lizards, with the anole lizards. I think that's how you spell it. And those were in the Caribbean islands, and how, you know, their different sizes and shapes are based on whether they're living on trees or on grass or on branches or in bushes. So even though they're living in the same space, they're occupying different niches. We're gonna talk more about niches when we hit the ecology unit coming up. Our next one is a shift in flowering time. And I know we don't think about plants every day, but plants indeed are out there reproducing too. They're having offspring, and those offspring go up to make the next generation. And with plants, what we're going to see is a gradient of early to late bloomers. And of course, blooming means you're putting out flowers. And so the ones that are blooming early are really only going to be able to mate with other flowers that are available at that time. And there's some overlap as you go through the season. But in some cases, by the time you reach the late bloomers, there can be movement of gene pools away from each other. So a shift in flowering time can lead to speciation of events because the pollen from one flower just won't be able to reach the other one. Another one we see is structural differences in sex organs. And this could be caused, obviously by mutation. A really popular story on this shift is a story of snails. And the snails, as it turns out, have, I guess that the spiral on their shells is either facing this way or that way. And I find this very difficult to draw. But as it turns out, Only snails that have the same spiral direction are able to mate with each other, because I guess their sex organ, from what I've heard, their sex organs are kind of up in the shell a little bit. And if their shell spiral is going in the opposite direction, they don't fit together anymore. And this is a mutation. It's something that occurs, but it makes it so that immediately at this point, you have this pre-zygotic mating issue that makes it so that they can no longer mate with each other. It's kind of interesting, but I guess that's the way it went down. Another one might be that there's something preventing the sperm from fusing with the egg. All right, so there's some pretty nice pre-zygotic barriers that are going to lead to speciation. There's also post-zygotic barriers, and those are mostly that hybrids tend to be sterile, which means they can't have offspring. They just can't. And so when you have two different species or a species coming together to create a hybrid, they may be able, like a tiger and a lion can get together and have an offspring, but those offspring are sterile. They can't produce offspring, or if they can, the offspring are so reduced in value over time that they end up just sort of burning out, from what I understand. So post-zygotic mechanisms, if they exist, are going to also drive speciation. So that was today's talk, and please fill out the Google form, and we will see you again.